What is up, mathletes? This is section 8.1.2, logs and log functions. We're going to graph these bad boys. Let's see what happens when we do that. Central question, how do we graph logarithmic functions? I thought you'd never ask. Well, here's how we're going to do it. We're going to use graphing tables, as always. All right, so check this out. This is how we do exponential functions. You might remember these from chapter 7. 2 to the x. This is... all these x values are, they turn into exponents. So 2, 1, 0, negative 1, negative 2, they're all the exponents are here, 2, 1, 0, negative 1, negative 2. And what comes out is what's called a power. So here, 2 squared is 4, 4 is a power of 2, 2 is a power of 2, 1 is a power of 2, 1/2, 1/4. These numbers are going to get smaller and smaller and smaller, and they will eventually approach 0. They do approach 0. They will eventually get as small as you want and get close as you want to 0. They will always stay positive. Notice these are negative numbers. These are negative numbers, even negative infinity represent all these numbers here that are negative, but these will always stay positive. What we can do, and notice we're going to use these two facts here later on, but when you put 0 as the exponent, the output is 1. And when 1 is the exponent, then it's the same base. It stays the same. So, looking at this red function right here, I just want to zoom out a little bit. Can I zoom out just a tiny little bit? Too much. So here, the input is an exponent, as I said, and the output is what we're going to call a power. And then the domain is all these x values. They go from negative infinity to positive infinity here. The range, it's going to get as high as you want, positive infinity, but the lowest y value is 0, and it won't actually even reach 0. So we're going to say that all these positive numbers are the range from 0 to infinity, not including 0. The intercepts, when x is equal to 0, the output is 1, so therefore it's a y-intercept of 0, 1. And we know when we graph it, it has a horizontal y equals 0, asymptote along the x-axis. Now, if we are going to take the inverse of this, let me say that again. If we're going to take the inverse, then everything gets flipped. Whatever the inverse is, we're going to interchange x and y, and all of a sudden, boom, on this blue side, you can see x and y get interchanged. And if you change this from a y to an x and x to a y here, then all of a sudden, all these y values turn into the exponents, negative 2, negative 1, 0, 1, 2, up to infinity. And the y values can go down to negative infinity. Those are the exponents. And we can back calculate the x values. So when the exponent is 2, 2 squared is 4. When the exponent is 1, 2 to the first is 2. 2 to the 0 is 1, and so forth. These are all the same numbers. They're just now in the x column instead of the y column. But you see what happens is that the input is now a power x. The x value is now a power, and the output is an exponent. Everything is switched, flipped. The domain of all these x values, the domain is going to be a power. The domain is going to be from 0 to positive infinity. From 0 to positive infinity here. These x values will never get negative, just like these y values over here never got negative. The range is going to be from negative infinity to positive infinity. And the intercepts, in red, the original function, the exponential function, had a y-intercept of 0, 1, and no x-intercept. But here, the inverse is going to have an x-intercept. It's going to be 1, 0, 1, 0. It's represented by this gray row right here. Where's the asymptote? It's going to be vertical asymptote. When we take the inverse, everything gets flipped over the line y equals x. Y and x used to be in different places. Now they got interchanged. So because of that, everything that was horizontal becomes vertical, and everything that was vertical becomes horizontal. Both of these, so the central question is, how do we graph a logarithmic function? Remember, it's the inverse of an exponential. So we can say that this inverse here is what it looks like. This is a logarithmic function. The vertical line test, yes, this blue function here passes the vertical line test, and it passes the horizontal line test. So that means not only is it a function, but it is also one-to-one, and there it is. We also can say that it's continuous. You can draw it with one swoop of your pencil. On ALEKS, this is what it's going to look like. Graph, the instructions will be basically, it's written with more words on ALEKS.com, but we're basically going to graph using 2 points and an asymptote. So, what we're going to do in order to graph f of x is equal to log base 2 of x, is we're going to need two initial facts. So you remember the two facts that I had from over here? One, when the input is 1, the output is 0. When the input is 2, the output is 1. We're going to use those here. And we don't even have to remember them. You can derive them if you want. 2 to the 0 is equal to 1. If you rearrange these into a logarithmic form, you get log base 2 of 1 is equal to 0. The exponent's all by itself over here. Here, 2 to the first power is equal to 2. That's something we can write down in exponential form pretty easily, and we can verify that it's true. But when you switch it around, the base is 2, the power is 2, and the exponent 1 is all by itself over here. Log base 2 of 2 is equal to 1. Now, it just helps it to be memorized that the log function has a vertical asymptote right here along the y-axis at x equals 0. So we're going to say that the vertical asymptote, we just know that it's going to be x equals 0, just like the parent function. It is the parent function that I talked about from before. So the 2 points are going to be from here, we know that when the input is 1, here, when the input x value is 1, then the output is going to be 0, just because we were able to translate it, and this is a fact that we've established. 2. The log base 2 of 2 is equal to 1. It's kind of like asking, 2 to the what power gives you 2? 2 to the what exponent gives you 2? It's going to be equal to 1. That's the exponent you need in order to go from 2 to 2. And that's that. So on ALEKS.com, you will graph in class, when I see you next, you'll graph a vertical asymptote along the y-axis, because that's what all log functions have as and yours will too, unless there's a horizontal shift that would change it. And then you're going to graph these 2 points, 1, 0 and 2, 1. 1, 0 is right here. It's the x-intercept. And then 2, 1 is over here. And these are the only 2 points you really need. And then once you have the vertical asymptote on the 2 points, you can just click graph a function, and it will. Let's see what this looks like with log base 3. Okay, so 3 to the 0 is 1. That's a fact we can write and translate into log base 3 of 1 is equal to 0. 3 to the 1 is equal to 3. Well, the base is 1. Base is 3, base is 3. Exponent is 1. It's all by itself, and the power is 3 here. Log base 3 of 3 is equal to 1. There's going to be a vertical asymptote, just like we will have memorized that a logarithmic function has a vertical asymptote. And so just like the parent function, it's going to be x equals 0 along the y-axis. The two values that we have are when x is 1, when the input is 1 to a log function, then the output is 0 here. Log base 3 of 1 is 0. We translated it from here, the exponential, to look at the logarithmic version. I want you to see if you can figure out if what is the log base 3 of 3, and it comes from this second fact right here. Anyway, you can graph the vertical asymptote. It's along the y-axis at x equals 0, just like the others. And then you can graph these 2 points, 1, 0, which is right here, and then 3, whatever this is, right over here. Boom. Click graph a function, and it'll graph all the rest of it. All right, 2 plus log base 3 of x. It's helpful to note that this 2 is on the outside, so that means it's going to be vertical, and then plus or minus, so that means it's going to be a shift. This is going to be a vertical shift of 2 from this one right here. We still need the same facts, the same input-output kind of exponential version. So if this is base 3 right here, base 3, then we can just use these same facts. 3 to the 0 is 1, 3 to the 1 is 3. Translated into logs, and this is what you get. The log base 3 of 1 is equal to 0. This 0 is the exponent you would need to go from a 3 to a 1, from 3 to a 1. And 1 is the exponent you would need to go from 3 to 3. This vertical shift is not going to affect the vertical asymptote at all. So it stays at x equals 0, just like the parent function. We got our two facts ready to go. So you can see here that this is log base 2 of 2. Pause. All right, I just had to throw in the 2 plus over here, just like the function is, just like you see here. It's 2 plus log base 2 of x. So let's choose 1 here, because we have the x, we have the x here is 1, and we just choose 3 also. 3 here. Because we can find log base 3 of 1, that's 0. We can find log base 3 of 3, that's 1. So 2 plus 0 is going to be 2, and 2 plus 1 is going to give you 3. And there's the 2 points you should plot. They're a little bit higher up, but that's the point. This is 1, 2. 1, 2 is here, and then 3, 3. 1, 2, 3 would be like right here, this point right here. You got a vertical asymptote along the y-axis at x equals 0, and so then click graph a function and you're done. Let's do a really tricky one. Here we can see this is 1 plus log base 2 of x minus 3. This is inside the function, so it's going to be a horizontal shift of plus 3 and then a vertical shift of plus 1 from here. We're going to use the same two facts just because it's a base 2, so we need to know that 2 to the 0 is 1, or equivalently log base 2 of 1 is equal to 0. Log base 2 of 2 is equal to 1. This is the same fact from before. Now, knowing that there's a horizontal shift of plus 3, that means that the vertical asymptote is going to be also shifted over 3 units. It's no longer x equals 0, it's at x equals 3. You have to ask yourself, what number can you subtract 3 by so that you get this value of 1 right here? Well, I know if I chose 4, then when I subtract 3, I would get 1, and I could take the log base 2 of 1. So we're going to choose x is equal to 4, because 4 minus 3 is 1. And then log base 2 of 1, I know what that is. That's 0. 1 plus 0 is 1. Let's do that again. Here, I have to ask myself, what number is that when you subtract 3, I get a 2? Because I can take the log base 2 of 2. That would be 5. 5 minus 3 is 2, and log base 2 of 2 is 1. This becomes 1 plus 1, which is equals 2. You can see everything gets shifted over to the right 3 units. 1, 2, 3 units. There's a vertical asymptote. Click that right there. And then we've got the values of 4, 1. 1, 2, 3. 4, 1 is right here, and 5, 2 is right here. Plot those 2 points, plot the vertical asymptote, and then on alex.com you can click graph a function and you're done. Are we done? We are kind of done. I kind of wanted to drop right now that my favorite teacher in high school was Mr. Schmidt. He taught physics. I took physics my junior year. It was just a junior level class where I taught it when I took it, and by far the guy who had the coolest demonstrations and had the greatest relationships with kids was Mr. Schmidt. And so, Mr. Schmidt, if you're out there, this video goes out to you. Take care, and I will see you in class.